Good afternoon, and thank you, Ilana. Or let me rather say good morning, or good afternoon, or good evening, wherever in the world you are. And welcome to this webinar on ePointing your router. Right, so Ilana has already done an excellent job of introducing the panelists. And sorry, Andre, we should put a picture of you up there as well. Right, let's get to the agenda. The agenda is, first of all, I'm going to say why. What is the ePoint? Then we'll look at the product range once we understand why we have developed the ePoint. Then we will look at fixed wireless access and what the promise of fixed wireless access is all about. We're going to also look at why co-locate your router. And when I say cable length, I'm letting the cat out of the bag a little bit, because we are going to look at cable length and what the issue is with cable length, and then look at the implementation of the routers, some of the applications, and then Ernst is going to talk to us about the future products. Right, so why? I'm going to start our presentation with a short video.
At Poynting, we often ask ourselves, what would make our customers' experience better? The ePoint is our answer. The Enclosure houses one of our world-class antennas, with space for a high-performance router of your choice mere centimeters or inches apart. By closing the distance from antenna to the router, we can drastically reduce the most important factor impacting router to external antenna connection: cable losses. The ePoint enclosure is designed to safely house various different router types, meaning you get to use whichever high-performance router you prefer, in conjunction with some of our best OMNI or directional antennas. The enclosures can accommodate routers of dimensions of up to 185 mm by 145 mm by 45 mm. Get your ePoint 1 or ePoint 2 for your OMNI or directional antenna needs. Both are future-proof and designed with superior patterns, covering the entire frequency range. Get your ideal CPE solution today. Connect with us for more information. Poynting, making wireless happen.
Right, so there you've seen a short video on what the ePoint is all about. Pardon me. So there we have a cutaway of the unit. There you can see a board router installed in the back, and that's what our ePoint is all about. Right, so let's first have a look at the issue surrounding cables. So if we say that we've got a certain level that we would like to get from a router, in this case, minus 78 dBm, for those of you that are familiar with the dBm levels. If we have an antenna that's receiving 10 dBi, then obviously our level will be at minus 68 dBm. The challenge, however, is that we need to connect the router, of course, to the antenna. And in this instance, I'm going to show you what a 15-meter antenna will do as far as the radio frequency losses are concerned. So if we install that, we will get about 8 dBs of loss, depending on the type of cable that you use, which takes you to minus 76 dBm. And that just means a lower signal. And then it means that the 10 dB that we originally had is now diminished to 2 dB. So you can quite clearly see that there's a substantial loss as far as the cable is concerned. So if we look at the ePoint, what we've done with the ePoint is we have a 10 dBi antenna. Again, the same scenario. We have 10. We're at minus 68 dBm. However, due to the fact that we've moved the router into the back of the antenna, we have these very short little cables, and those short little cables will only have a loss of 0.2 of a dB, which means it brings us down to minus 68.2 dBm. So you can see there on the graphic a substantial improvement in the losses, which allows for a much better received signal. So looking at just at a table there, you can see what a 15-meter cable, the losses of a 15-meter cable, and if we compare that to a 300 millimeter RG58 cable, you can see that it has substantially less losses, and our improvement is 7.8 dB. Right, as far as the product range is concerned, the ePoynt 1 is an omnidirectional antenna. As the name suggests, it has an omnidirectional radiation pattern or receive angle, and it makes use of two cross-polarized dipoles. This is configured in a 4x4 MIMO type of configuration for LTE and 5G. Covers the frequency ranges from 617 all the way up to 3,800 megahertz with a peak gain of 3.5 dBi. So as far as the Wi-Fi, yes, we have Wi-Fi antennas built into the unit as well. And the 2x2 Wi-Fi antennas will handle both the 2.4 and the 5.8 gig with a range of 5 to 6 gigahertz at the upper frequencies, with a peak gain of 5 dBi. So into the ePoynt 2, this is our unidirectional high gain antenna, cross-polarized on the high gain antenna. But not only do we have a cross-polarized high gain antenna in there, we've included the two 2x2 omnidirectional antennas from the ePoynt 1 in the ePoynt 2 as well as the high gain antenna. So again, the same frequency range, 617 to 3,800 megahertz, with 11 dBi on the high gain antenna and 3.5 dBi on the omnidirectional as before. And then there's our MIMO antennas built in there again as well, with the same specs as previously. So the enclosure size, you can see the enclosure size there. So the router size that we can accommodate, as we also saw on the video, is as you can see on the screen over there. Right, so let's look at omnidirectional versus directional antennas. Omnidirectional, as the name suggests, allows the signal to be received from multiple towers around the residence, as you can see there. And that allows the router inside to connect to the best possible tower based on the signal to interference and noise ratio, or the RSRQ, the received signal quality. However, if we are in a scenario where the towers are further away from us and our residence is far away from and there's a single tower, we can use the directional antenna, as you can see, and the directional antenna will be focused on a particular tower or node B. Now, having said that, with the inclusion of the omnidirectional antenna in our ePoynt 2, we can have the following scenario. Yes, whilst that comes up, let me just explain that what you're seeing on screen. The directional antenna has the ability to discriminate against signals from other towers, lowering the signal to interference, particularly interference and noise ratio. However, with the omnidirectional antenna built into it, we've got the following capability. Looking at the omnidirectional antenna, if we have towers in the vicinity that can be included, and for instance we have a 4x4 router that's installed in the unit, we can make use of both the omnidirectional as well as the directional and antennas. Now, I personally have installed here in the RF shack here behind me such a router, a 4x4 router, and I can tell you the performance is excellent. Andre.
Thanks, Peter. The one thing I just wanted to mention to people is something we're starting to exploit more and more, is the fact that that antenna's got two directional cross-pole. Cross-pole will give you always two data streams, but it's very difficult to get 4x4 MIMO to work properly. In other words, to get any more MIMO effect, you normally have to get reflections from other directions. Now, having two OMNIs is actually excellent for that purpose as well. So if you had like a building next to you or behind you, the OMNI would be able to see it, but the directional not. So if a reflection comes from there, you'll get a very nice uncorrelated path for getting, say, three streams. And if there's another reflection, you'll be able to get 4. So it is actually quite wise to have antennas with different pattern shapes when you do 4x4 MIMO. And I think this is something we most probably will continue. This was as a result of need. We couldn't fit high gain antennas in there. But what it turns out, I think, is some advantages which we actually didn't foresee when we designed it originally. Thanks, Peter.
Thank you, Andre, and that is exactly what I found in practice as well, Andre. Right, so let's look at fixed wireless access. So let's have a look at this is a good antenna. This is one of our antennas, and we receive a good signal on the outside. Now, something that you need to know is that from the outside to the inside, you can lose anywhere between 16 and 20 dBs. Now, to put that in perspective, that means between 40 times and 100 times smaller signal inside of the building. Right, so in this instance, we also now have the RF losses from the RF cable. And as you can see there, we feed it obviously into the residence. And you can see that we've lost a bar on our graph there. Contrast that to our ePoynt 2 or ePoynt 1 for that matter. Our ePoynt, of course, has an excellent signal outside of the building. But as we feed a Ethernet Cat6 cable down into the residence, we lose nothing as far as the signal is concerned. And inside the residence, you will see an almost perfect signal, similar to the signal that you see outside of the residence. Now, for the next the next slide I'm going to show you, I just want to put this in perspective. This table is from Mobility Arena and from opensignal.com. And you'll see here that the average from all of the mobile network operators in South Africa for download is around 20.39 megabits per second. I show you that just so that I can put in context when I show you the next slide. So here we have our two scenarios again. The one at the top, of course, is our good antenna, but we have the losses of the RF cables. And this is typically some measurements that I've done over a period of time. Download around 13.25, upload at around 6.55. Now, if I contrast that with our ePoynt, I was getting around 28.33. This was over a period of time in the download, and around 14.86 over time. That means it's a download improvement of 2.14 times and an upload of 2.27 times the contrasting download from the router at the top that had the RF losses from the RF cables into the residence. Right, so just some photographs of some of the devices. That happens to be a Teltonica RUT240 that I've installed in the back of the ePoynt there. What you see on screen now is what is known as a SIM extender, and you can see on the photograph to the right at the bottom the SIM extender cable leading into the SIM tray of the router, so that one can access the insertion of the SIM card from outside. In other words, if you don't have that SIM extender, you would actually need to take the back cover off in order to change SIMs, just to make it a lot easier to change SIMs. What you see there now is the window suckers. I've got it installed outside of my the Radio Shack, my lab here, on the window, and that's me putting it on the window. It works perfectly well on the window there, and then you can obviously install it on the mast. We'll talk a little bit more about different installation options just now. Whilst I'm showing you on the window there, the unit can also be installed on the inside. Unless you have metallized window panes, those metallized that is a bit of a sun shield, a normal window pane will offer almost zero resistance to the electromagnetic wave coming in, so it's electromagnetic transparent. So as long as you know that on that side of the building you actually have a tower, it's perfectly fine to also install it on the inside, and then you don't have any issues with getting the Ethernet Cat6 cable from the outside into the building. And then as you know, on Ethernet cables, you have a 100-meter limitation. So you can go 100 meters from where the unit is installed to where your closest indoor access point or your Ethernet switch is inside. So let's have a look at the two installations here. On the left-hand side is that RU240 that I've installed inside the unit, and then on the right-hand side is a 4x4 single board router that I've installed. You can see the installation there. That is the cell main and the cell diversity. In the case of the ePoynt 1, that would be the vertical and horizontally oriented and omnidirectional antennas. And in the case of the ePoynt 2, that is the directional antenna that is at the top. And then when we look at the bottom on both sides, there is in the case of the ePoynt 1, that would be the 45-degree left, 45-degree right polarized antennas. And in the case of the ePoynt 2, that would be the omnidirectional antenna that you connect to those connectors there. So the Wi-Fi, you'll see the Wi-Fi there on the left-hand side. So the top one being the horizontal, the bottom one being the vertical. And then down at the bottom here is the Ethernet feed through. And then to the left of that are two knockout slots for the optional SIM extender cables that you have here. So you can have up to 2 extension cables connected to the front plate here at the bottom. Then we also have an optional USB feed through. So if the router that you're installing has a USB input, you can fit a USB pass through so that you don't have to take the cover off to get into the USB. Then on the just to the right of that is our ground pin. Very important to ground your router particularly when you're installing on a pole. And then right at the top we have a little also an optional little bracket for your GPS antenna if you wish to put a GPS antenna. And I incidentally have put a GPS antenna on one of the units that I've got outside here. And then on the right-hand side, you'll see the single board 4x4 router that's installed there and the pinouts. Right, then as far as mounting options are concerned, as I mentioned before, and my apologies if you hear some, if you do hear some dogs barking. This is one of the challenges of presenting from home. Back to the slides. The pole mount you see on the left-hand side there, and then the wall mount, and then on the right-hand side is the suckers that I showed you on the window. And just incidentally, we've had one of our units stuck on the wall at the office for more than a year now. In fact, I think it'll be probably a year and a couple of months, Stephen.
Yes, that's correct. September last year it was installed, and it's still sticking on the window. So it's quite durable in that sense.
Excellent. Right, so let's look at the applications. The ePoynt 1, remember that's the omnidirectional antenna unit. That is typically the type of unit that would work very well in a commercial and industrial setup, where you have towers in the enclosed vicinity to the complex, and then in an urban area, similarly, where you have towers, NODs that are close in, and you would like to make use of the omnidirectional capability to receive signal from multiple towers around the site. Then the ePoynt 2, as we mentioned before, it will work well in a commercial and industrial and in an urban area, but it's really in the farming and agricultural sector, as well as the rural areas, where you are really going to need that 11 dBi of the directional antenna, that the ePoynt 2 will come into its own. Then, as far as a bit of a application matrix is concerned, in the dense urban area, as I've just mentioned, the ePoynt 1 shines very and works very well in that type of environment, and very much so in an urban area where you've got dense buildings and towers close in. It will also work in a suburban area, and the decision criteria there would be if you have enough towers for the omnidirectional capabilities. And then in the rural area, we're not saying that it will not work there, but obviously one will need in that rural or open farming area, one would need to have multiple towers relatively close in to be able to deploy a omnidirectional antenna. Then the ePoynt 2, the only reason we're giving it 2 ticks for dense urban is that the directional antenna that's built in there may be a bit of an overkill. So it's not that it won't work, but it's definitely optimized for dense urban areas where you would like to make use of the combination of a directional and omnidirectional antenna, and definitely in a suburban and suburban residential area as well. And then where you're really going to need it is in that rural farming area, where you are most definitely going to want to use that 11 dBi directional antenna to draw in those towers that are far away from your farm residents. Right, then future products. I'm going to hand over to Ernst. Ernst is going to take us through the future products. Ernst?
Thank you, Peter. And yeah, I think you can have a sip of water and rest your voice a little bit. And yeah, just before I get into the future products, just to remind everyone that there is a Q&A tab. So if you have any questions and any questions for us, we'll be more than happy to answer it there. But yeah, just to give everyone a bit of a sneak peek of what's to come with the whole ePoynt range and with what we'll be focusing on is an ePoynt 62. So it will be a unidirectional cross-polarized Wi-Fi only antenna enclosure. So this will then consist of 4x4 MIMO Wi-Fi antennas. So these antennas will be dual band, and they'll operate or cover the 2.4 gigahertz band as well as the 5 all the way to 7.2 gigahertz band. So why all the way to 7.2 gig? But that's just for Wi-Fi 6E applications. That's to make it future-proof, and this will be ideal for any access point or point-to-point communication deployments. And yeah, it will be in the same form factor as our current ePoynt 1 and 2. and it will have the same size and the radar dimensions as well as the router dimensions. So yeah, this is our unidirectional or directional Wi-Fi only ePoynt that will be coming out not soon, but next year, in the realm of next year. And yeah, just on to the next one, Peter, if you don't mind. Thank you. And then another addition will be an ePoynt 4. So this will be a complete new form factor to the ePoynt series. As you can see on the right, it's more of a dome type of structure, but yeah, then on the left, you can see just a bit of a see-through where you have the antennas at the top and you have the router or modem at the bottom. So this will be an omnidirectional cross-polarized antenna enclosure. So this will consist of 4 LTE as well as 4 Wi-Fi antennas. Now the LTE will work from 617 megahertz all the way to 3.8 gig, making it ideal for current LTE as well as 5G deployments, and it is covering that lower 617 megahertz band, LTE band 71, that is, I think, becoming quite apparent in all the antennas and they're important to have. And yeah, the Wi-Fi antennas will be dual band as well, so that they all cover the 2.4 as well as the 5 to 6 gigahertz bands. Now, what makes this unique is that all 4 antennas will be cross-polarized, meaning that all 4 LTE and Wi-Fi antennas will be horizontal and vertical as well as plus minus 45 degrees. This will ensure optimal MIMO performance and isolation between the antennas. So this is what you actually would want within your antenna, within your MIMO antenna. And yeah, the router size is a tad bit smaller than our current ePoynt 1 and 2. It's 125 by 125 by 50 millimeters. So it is a tad bit smaller, but I did have a look at the current router or modems available, and you will still be able to fit in quite a variety, like your Huawei's, your Teltonicas, your Advantech, your Cellaway, and all those routers, that they will still be able to fit inside that with those dimensions. So that won't be a problem. But yeah, this will be a complete new form factor. And as you can see at the bracket at the bottom, it is a unique thing where you can feed your Ethernet cable through that, and there's a bit of a protection there. So just to protect your cable from any environmental conditions of some sort, if this is mounted outside on a pole or against a wall. So that is something to look forward to with our ePoynt range, and this will be coming next year and something to look forward to. But yeah, and just the next slide there, Peter, just to show where the ePoynt 4, where it can be used. And this will be a very versatile antenna, as it's LTE and Wi-Fi. It can be used for commercial and industrial applications as well as for urban and rural with the bracket, because it can be pole as well as wall mounted. And then it can be used for farming and agricultural, because it can be mounted onto a vehicle with the unique base design. And then lastly, it can also be used for marine and coastal, because the unique base design, you can take that bracket off at the bottom, and then those pass-through holes is the same as our current marine ones. And it can be mounted onto a pole for marine applications. So it's yeah, we really did think of everything with this one, and definitely something to look forward to. But yeah, that's all from my side. Thank you, Peter.
Thank you, Ernst, and thank you for that, Elana. And Elana, over to you.
Thanks. I want to ask the other panelists to switch on their videos. I want to ask our attendees to please scan our QR code and subscribe to our YouTube channel. This presentation will be sent out to you in the next couple of days, and we will load the video onto our YouTube channel if you want to have a look at it again. So please look at that.